Hey, hi, Rajan this side. Welcome back to the channel. For today, we'll discuss all four problems asked in today's LeetCode Weekly Contest 482. Let's start with the first problem. It says you are given an integer array nums of length n. Now, you can choose an index I, and the index can vary from index 0 to n minus 2, right? And for each chosen index I, what you can do, you can first find out the prefix sum of I. So prefix sum of I is nothing but the sum of all the number from index 0 to I. And the other thing which you have to find out is suffix mean of I. So suffix mean of I is nothing but the minimum number on the right side. Right side means from index I plus 1 to n minus 1, right? So find out these two value for each index I. Now for each index, the score would be prefix sum of I minus suffix mean of I, right? And among all such indexes, we have to find out the index where this score is maximum, right? So we have to find out the maximum score over all such valid split indexes, right? So yeah, it's a implementation problem. So let's directly look at the code. Here is the code. So as per the problem statement, we have to find out the suffix mean for each of the index, right? So that's exactly what I have done. I have first calculated the suffix mean. So suffix mean of last index n minus 1 is nothing but n, I mean, like nums of n minus 1 itself, because there is just one number. Now from index n minus 2 to index 0, what I have done, I have just calculated suffix mean of I by using the information of suffix mean of I plus 1. So it's a very standard concept of prefix and suffix sum. So suffix mean of I is nothing but minimum of nums of I comma suffix mean of I plus 1, right? So this is how you calculate suffix mean for each of the index. Now once you calculated the suffix mean, the job is easy. Just have a variable prefix sum and the maximum score. Initially it is int mean, not int mean since it is long, so it's a long mean. So here I have taken minus 10 to the power 15. Now go through each of the index from index 0 to n minus 2. So I is less than n minus 1 as per the problem statement. If you see, I is from 0 to less than n minus 1. So that's exactly what I have done. Now for each index, calculate the prefix sum. So prefix sum of I is nothing but sum plus equals to nums of I, right? So this will calculate the sum of all the numbers from index 0 to n minus 1, right? So this is nothing but sum of all the numbers from index 0 to n minus 1. So this is nums of 0 plus nums of I plus nums of 1 plus nums of 2 up to nums of I. So this is how you calculate prefix sum. Now your max score is nothing but maximum score comma your prefix sum minus suffix mean of I plus 1. I mean, it's exactly what like what the problem statement says. So suffix mean of I is nothing but the minimum number from index I plus 1 to n minus 1, right? So here that's exactly what I have calculated here. So yeah, after that just return max score. Yeah, it's a just implementation problem. I hope you had solved this problem. So yeah, let's look at the second problem now. So in second problem, you are given 5 integer cost 1, cost 2, cost both, need 1 and need 2, right? And there are three types of items available. An item of type 1, it cost of 1 and contributes 1 unit to type 1 requirement, right? So we have to fulfill these two requirements, need 1 and need 2. So if you take one unit of type 1, it will cost you cost 1 and it will fulfill 1 unit to this requirement of need 1. And same for type 2, if you take one of type 2, it will cost 2 and it will fulfill 1 unit for need 2. Now there is an item of cost both, like type 3, it will cost you cost both and it will contribute 1 unit to both need 1 and need 2, right? And you must collect enough items so that total contribution towards type 1 is at least need 1 and total contribution toward type 2 is at least need 2, right? So we have to fulfill both need 1 and need 2, right? So you must have at least need 1 and at least need 2, uh, and like you have to find out the minimum possible cost to achieve this requirement. So we have to fulfill these two requirements. Your need 1 must be fulfilled and need 2 must be fulfilled, like so. Yeah, it's a easy problem also. Let's see how we can approach it. we know that if you take type 1, right, if you take type 1 or type, let's say this is type 2 and this is type 3, right, it will cost you cost 1, it will cost you cost 2, it will cost you cost 3, right, and it will fulfill need 1 unit for need 1, it will fulfill 1 unit for 1 need 2, this will fulfill 1 need 1, and this will fulfill 1 need 1 plus 1 need 2, right, it will fulfill 1 need 1 and 1 need 2. So if you see here, this is contributing both need 1 and need 2, right, by 1 unit. So first case is very obvious. If your cost 1, right, so let's say you want to fulfill 1 need 1 and 1 need 2, right, so there are two possibilities, two optimal possibilities. One is either you take 1 unit of cost 1 and 1 unit of cost 2, so here your total cost would be cost 1 plus cost 2, and or if you take just cost 3, right, so this will also fulfill 1 unit of need 1 and 1 unit of need 2. So if cost 1 plus cost 2 is less than cost 3, let's suppose, then isn't it optimal to choose always this cost 1 plus cost 2, right? So what we can do to fulfill 1 unit of need 1 and 1 unit of need 2, what we can do, we can first check like which one is minimum. If cost 1 plus cost 2 is minimum, I will take this to fulfill 1 unit, or if cost 3 is minimum, I'll take cost 3, right? So let's say this is your cost 1, like, so this is your need 1, and let's say this is your need 2, right, let's say need 2 is more, right? So if you see here, till here, like, you have to take both, right? So what we can do to fulfill these conditions, right, where you need 1 unit of need 1 and 1 unit of need 2, what I can do, so that value would be minimum of need 1 and need 2, right? So your cost is nothing but your total minimum cost is nothing but minimum of these two, minimum of need 1 comma need 2 into, for the common values I will take minimum of these two, right, minimum of need 1 plus need 2 into minimum of cost 1 plus cost 2 comma cost 3, right, because for minimum of need 1 and need 2 you would have uh, you must have both need 1 and need 2, right? So minimum of these two into minimum of the cost 1 plus cost 2 or cost 3, right? So this will fulfill your common values. Now for the remaining one, right, so just check uh, which one is maximum. Either need 1 is max, so this could be need 1 also, right? So if need 1 is greater than need 2, in this case need 1 is more, so here your minimum cost plus equals to whatever the remaining value, right, that is nothing but need 1 minus need 2 into, up see here, so in this case so let's take one example. Let's say your need 1 is 5 and need 2 is 3, right? So need 1 you have 1 2 3 4 and 5, and need 1 is 3, need 2 is 3. So for these values, right, where you have both need 1 and need 2, so I have fulfilled using this condition, right? So which one is minimum, either cost 1 plus cost 2 or cost 3. So based on the minimum value, I will fulfill these condition. Now you left with 2 need 1, right? So this 2 need 1 can be fulfilled by two way. Either you fulfill using cost 1, or you can also fulfill using cost 3. So this is nothing but this into minimum of cost 1 comma cost 3, right? So in this case you would be having some extra need 2 if you are filling with cost 3, right? But like in the problem statement, it only says you must have at least need 1, like you must have at least need 1 and at least need 2, like it doesn't say that you have to be strictly need 1 and need 2. That's why like I can also fill with cost 3. So though it will having some extra need 2, but that's fine. Else the last condition, let's say if need 1 is more than need 2, let's take one example. Let's say need 1 was 4 and need 2 was 6, right? So 1 2 3 4, and 1, 2, 3, 4, 5, 6. So for these four values, right, for these four values, I'll be I'll be fulfilling with like either minimum of cost 1 and cost 2 or cost 3, like so based on the minimum value. Now for the remaining value, again the same process. The answer is nothing but mean cost plus equals to whatever the difference is, that is nothing but need 2 minus need 1 into minimum of, see again the same case, for these two I can either fulfill with type 2 or type 3, and the cost is nothing but cost 2 and cost 3, and that's it. I mean it's easy problem. If you just spend some time you would figure it out, right? So for the common values I fulfill with either cost 1 plus cost 2 or cost 3 based on like whichever is minimum. For the remaining one I can fulfill with the corresponding type or type 3. So if need 1 is more I can fulfill with cost 1 and cost 3, or if need 2 is more I can fulfill with cost 2 or cost 3. So yeah, that's all about second problem. And now let's look at the code. Here is the code of second problem. This code is exactly how I have explained in the explanation part. So I would highly recommend to check out that. So you are given cost 1, cost 2 and cost 3, right? So instead of cost 3 here it is given cost both, but that's fine. Now need 1 and need 2, right? So first find out for the common values, like which one is optimal, either cost 1 plus cost 2 or cost both. So just take minimum of these two and into minimum of need 1 and need 2, right? Because if you see here, so in this test case you had need 1 as 5 and need 2 is 3, right? So whichever is minimum, right, the common values here, if you see 4 are common, 3 here 3 is common. So for these, so there are two possibilities, either you fill with type 1 and type 2 separately, or you take type 3, right? So that's what I exactly have done. So minimum of cost 1 plus cost 2 and cost 3, or into minimum of these two, right? So this will fulfill the common values. Now for the remaining one, just check which one is remaining, either need type 1 is remaining or type 2. So if type 1 is remaining, you can fulfill with the remaining with type 1. So this is the remaining requirement. Now you can fulfill with either type 1 or type 3, right? And if type 2 is remaining, then you can fulfill with cost 2 and cost 3, right? And at the end return your minimum cost. So yeah, that's all about the explanation and code. Now let's look at the third problem. So in third problem, you are given a positive integer k. Now we have to find out the smallest integer n that is divisible by k, that consists of only digit 1 in its decimal representation. For example, 1 1 1 1 1 1 and on, right? Now we have to find out the minimum number of digits in the decimal representation of n. If no such exists, just return -1, right? So for example, if you see here k is 3. Now let's see what is the minimum number that is divisible by k and has only 1 in the digits, right? So 111 is the minimum digit. So before 111 you had 1 1 1, right? But 1 and 1 1 is not divisible by 3, right? So the minimum number that is divisible by 3 is 111, that has only 1 in its um, decimal representation. So for 7 it is 6 number of ones, right? So in the answer you don't have to like return the integer itself, you just have to find out how many ones are there. So here if you see, so instead of returning 1 1 1 1 1 1, you just return 6 number of 6, right? So 6 represents how many ones are there. So actually it's a brute force problem. I mean it's not like you have to find out some optimal solution. So what you can do, let me explain it. To solve third problem, we are going to apply a brute force solution. So we start with num equals to 1, and initially the count of 1 would be also 1, right? So initially you start with 1 and your count is also 1. So count 1 would tell you how many ones are there in the like in the decimal representation of num, right? So what will the first step? First step would be check whether this num is divisible by k or not. So if this num is divisible by k, right, means that this is the minimum number, right? So just return count of 1, return this count of 1, because this is your answer. Otherwise, if this is not divisible by k, what would be the next number? Next number would be just add 1 like just append 1 in the decimal representation. For example, you start with 1, the next number would be 1 1, again the next number would be 1 1 1, next number would be 1 1 1 1. So you keep on doing the same process. You just check if this is divisible by k or not. If that is divisible by k, you return count 1. And remember, each time your count 1 your count 1 plus plus, just do keep count 1 plus plus, because you add 1 at the end, right? So digit 1 at the end, so count 1 plus plus. So just check if 1 1 is divisible by k or not. Yeah, like if that's not divisible, go to triple one, then 4 ones. Just keep on doing this process, right? As soon as you get first number that is divisible by k, that is your answer, right? But interesting thing, how do you find out the case when the answer won't exist, right? So if you observe it carefully, your k is up to 10 to the power 5, right? And if you see, so let's see what is 1111 modulo k. Can I say this is nothing but, so 41 is nothing but 1000 plus 100 plus 10 plus 1, right? So this is nothing but 1000 plus 100 plus 10 plus 1, right? This 1111 modulo k. And we know from the number 3 property, a plus b plus c plus d modulo k is nothing but a modulo k plus b modulo k plus c modulo k and so on. So this is nothing but 1000 modulo k plus 100 modulo k plus 10 modulo k plus 1 modulo k and so on, right? So that's exactly what I am going to do here. So we know that only remainder matter, right? So this num like doesn't have to be 1111, it can be remainder of this also. So each time what I'll be doing to go to the next number, like so to convert 111 to 1111, what I can do 111 into 10 plus 1. So this is nothing but 1110 plus 1. This is nothing but 1111. This is exactly what we were looking for. So to convert, so to add one extra digit at the end, what we can do, you can just multiply with 10 plus 1, right? Multiply with 10 plus 1. So to go from num to the next number, we can do num into 10 plus 1, right? And each time what we will do, we will update num with each time we will do num modulo equals to k. So each time this num would be having the remainder with k, right? So why I'm doing this remainder is because let's say we know that this k is only up to 10 power 5, right? So and since we are taking remainder each time, we are each time doing, so after after converting to the next number, like the next number means appending one at the, I'm taking modulo with k, right? So if you take modulo with k, your range would be from 0 to k minus 1, right? 0 to k minus 1. And so this remainder is going to be from 0 to k minus 1. So if you notice it carefully here, let's say at some point your remainder gets repeated, right? Let's say at this point your remainder is something, let's say x. Let's say you then append 1 at the end and you find the modulo. Again, let's say you keep on doing this process and you don't find the answer, right? Don't find the answer means your num modulo k is not equals to 0. Let's say after some point you again found x. What it means, this x is repeated, right? This x is repeated once again, so it will again repeat after some point, again it will repeat after some point, so you will never find the answer. So answer would exist only if your remainder is unique and you find the answer. If your remainders gets repeated and you don't find the answer, you will never find the answer, because this will repeat once again and it will be kind of a infinite loop. So so I hope you understand. We just have to keep track of all this remainder also. If the remainder gets repeated, then your answer won't exist. Otherwise, your answer exists, and you keep on doing this process. So we will be doing this process indefinitely. So indefinitely means we will be having this up to while true, like so the loop would be infinite loop. But but as soon as your remainder gets repeated, you return -1, and if the remainder are unique and you find the answer, just return like whatever your count 1 is there. So here the complexity is order of k, because we will be going through each unique remainders from 0 to k minus 1, right? So I hope you understand. Just spend some time, it's a easy problem. So let me quickly recap. So you start with num, initially count 1 is 1. So we would be having a while loop. You will be giving or doing all this process in a while loop, and while loop would be indefinitely right? So it will be having while true. So first check if your num modulo k is 0 or not. If that is like anyway 0, just return count 1, otherwise append 1. So do count 1 plus plus append 1. Now to append 1 we will be using this formula, num equals to num into 10 plus 1. So it will, so for example 1 1 1 1, to convert this to this you just do this into 10 plus 1. Then take modulo with k, so num modulo equals to k, because we would be having so we have to deal with modulo, right? So like your number doesn't have to be the exact number, it can be modulo also, the remainder with k. So just check if this remainder value is already visited or not. If that is already visited, your answer won't exist, then just return -1. Otherwise you keep on doing this process, right? So in this case you will be having all the numbers from 0 to k minus 1. You would only like visit all the numbers from 0 to k minus 1 for the complexity order of k. Here is the code of third problem. So this code is exactly how I have explained the explanation part. So this is your given integer k. You start with num equals to 1 and count equals to 1. Now this is your unordered mat to keep track of all the visited remainders. So this is a do while loop. So first check if your nums is your current number is remainder, like the remainder of the current number with k is 0 or not. If the remainder is 0, just return count 1. Otherwise you append 1 at the end, right? So count 1 plus plus num so to append 1 at the end, as per the explanation part, just do num equals to num into 10 plus 1, do a modulo, then check if the remainder is already visited. If it is already visited, return -1, because this is again going to repeat after some time, so your answer won't exist. If that is not visited, just visit it, and that's it, while true. So this process would be indefinitely, but it won't be exactly indefinitely, because it will be it will go only up to k. So the complexity is order of k, so it will visit all the remainder from 0 to k minus 1 only one times, right? So yeah, that's all about third problem. Now let's look at the fourth problem. In problem 4, you are given two integers low and high. Now an integer is called balance if it satisfies both the following condition. First condition, it must have at least 2 digits. The second condition, the sum of digits at even position must be equal to sum of digits at odd position, right? And the first digit is the its position number 1. Now we have to find out the number of balanced integer from range low to high, right? So from this range low to high, like in this range low to high, we have to find out how many balanced integers are there, and each balanced integer satisfies these two conditions. First condition, it must have at least 2 digits, and the sum of digits at even position must be equal to sum of digits at odd position, right? So so after looking at the problem statement, you might know that this is a digit DP problem. So it's a standard digit DP problem. Let's see how we can approach it. We'll solve 4 problem using digit DP. So I hope you are aware of digit DP. If you're not, I would highly recommend to solve at least one problem in digit DP, then come back to this video, because here I won't be able to explain complete digit DP in this video itself. So I can explain you how to approach digit DP in this problem, right? So yeah, to start with, let's say you are given low, right, and high, right? So we have to find out how many balanced integers are there from this range low to high. What if I have a function, let's say solve function, that takes integer n, right? So that will tell you how many balanced numbers, so how many balanced integer are there from range 1 to n. Let's say this gives how many balanced integers are there from range 1 to n. Since we have to find out from low to high, what we can do, we can do solve high minus solve low minus 1, right? Low minus 1. So in this case, so if you have this function, then you don't have to worry about low to high, just do solve high. So this will give you all the balanced number from 1 to high, and just subtract from all the numbers from 1 to low minus 1. So what you will left with all the numbers from low to high, right? So that's the alternate way to find out the balanced integer from low to high. So that's the first step. Now let's see how we can build this solve function. So this solve function will give you all the balanced integer from 1 to n, right? So for this given integer n, we will first convert into its string, right? So let's say this int is 1, let's consider 1 2 3 4 for example. So we will convert this into string format, right? So this will be a string of 1 2 3 4, nothing else. So there is a function called toString that converts the integer to a string, right? That to convert into a string, you can call toString function. So let's say this is your given integer, right? In the string format. So if you notice it here, so how many numbers are there from 1 to n that is less than or equals to this 1 2 3 4? There are multiple numbers, right? So there are exact 1 2 3 4 number. uh, so what I mean is 1 2 3 4 5 1 1 1 1 1 2 3 1, all these number are less than this, right? So if you see here, 1 can be represented as 0 0 0 1, then 0 0 0 2, 2 is represented as this way. Let's say you have 0 1 1 2, this is also less than this, right? So these are the numbers that is less than 1 2 3 4, right? So what we will do, we will try to build these numbers. But if you see, so like if you remember, in the problem statement we have to find out all the balanced number uh, from low to high, right? So here, like alternatively, we have to find out all the balanced number from 1 to n, and balanced number consists of two digits, at least two digits, and the sum of digits at even position is equal to sum of digits at odd position, right? So instead of finding all the exact sum of digits at like either even or odd position, we will be having a diff. So diff will tell you the difference, right? Because at the end we have to find out whether the difference is 0 or not. Difference 0 means the sum of digits at even position at is exactly equal to sum of digits at odd position. So we would be dealing with diff, right? So I mean, I just want to let you know how to start with the digit diff, right? So we have to build all the numbers from 1 to 1234, right? 1 to 1234. So for all the numbers, we will try to find out how many numbers are there whose number of digits is at least 2 and difference is 0, right? So this will be a recursion. So it will be so in digitdp we, I mean, almost 99% of time we solve with top down dp, top down dp, top down dp, right? So it's a dp problem, so you must know at least how to solve a dp problem also. So it's a top down dp. Let's see how we can approach now to solve this problem using digit dp. So we know that your n is 1 2 3 4, right? So there are 4 digits, so there are 4 places that should be filled up. So there are 4 places. Let's say at first place I kept, so there are like multiple ways to keep the first number, right? Since the number is, for the first number is 1, you tell me, pause the video and you tell me what are the options you have for the first digit. It is only two possibilities are there. Either you keep 0 or you keep 1. You cannot keep 2. If you keep 2 here, right? If you keep 2 here, then your number would be more than 1 2 3 4, right? This is the 4 digit number. So it means that these numbers has to be filled up either with 0 or any other digit. So the minimum number that could be filled up is 0 0 0. So if you have 2000, that is more than 1 2 3 4. So the only possibilities to keep digit at first place is 0 and 1. We cannot put 2 at the first place. That's why if you keep 0 or you keep 1. If you keep 0, right? If you keep 0 at first place, so let's say this is your digit, right? These three places are empty currently, right? Because you are currently at the first place. And again here also your next three places are empty. So if you keep 0 here, let's see how many what are the possibilities are there. So see, if you have 0 here, what it means, if you have 0 at the first place, then your number can only be up to 3 digit number, right? And all 3 digit number will always be less than 1 2 3 4. So we can anyway keep number from 0 to 9 and any of the place, right? So how many options, so how many numbers are there? 10 into 10 into 10, total 1000 possibilities are there. See, if you keep 0 here, means that now this number can only be up to 3 digit number. So for 3 digit number, and 3 digit number will always be less than 1 2 3 4, right? So we can keep any of the number from 0 to 9. Now let's suppose this case. If you keep 1 here, right, then for this number, how, so how many possibilities are there? Here you have 2, right? So you can only keep 0, 1 and 2 at this place. That's because let's say you kept 3 here, then your number would be 1, 3, and for the next two one place number, let's say your minimum number is 0, 0. See, 1300 is more than 1, 2, 3, 4. So that won't be possible. So we cannot keep 3 here. So we can only keep 0, 1 and 2. What it means? It means that if you have a prefix that is exactly same as the original prefix, then you can only keep the number from 0 to that digit minus, so 0 to that digit, that's it. So I want to build what would be your state of DP. What are the things, so state of DP means, so I hope you know in DP problem we, like, you must have some state, right? So DP of X, Y, Z and all, right? So these are the states. What are the arguments that are changing? So here first is your index. First is index. uh, Index. Index means at which position you are. So if you are at this position, your index is initially 0. If you are next position, index is 1, 0, 1, 2, 3 and on. Index is changing. The second thing which is changing is the difference, right? So difference means, so we have to find out all the digits whose difference is 0, right? Difference means the sum of digits at odd even position and the sum of digits at odd position. So once you add the digits, right? So here let's say you add 0. You just, so if it's a even position or it's a odd position, just, so for even position, so positions are 1, 2, 3, 4, 5, right? So let's say you start with 1. For even position you do plus, and for odd position you do minus, for example. So here you would be having a difference, right? We anyway have to worry about whether the difference is 0 or not. So second thing is 0. The third thing is whether you what should be the digit, which digit which you should place. So there are two things required for that. One, whether you started or not. Started in the sense, if you have 0 then you have not started. So for the initial zeros, right, for the initial zeros I would treat it not started, right? Not started means, let's say you want to keep, so you want to go from 1 to 1 2 3 4, right? So 1 to 1 2 3 4. So for those numbers, let's say I kept 0 here. So what it means? It means that I have not started yet. If you have 0, because your minimum number should be 1. So minimum, so if your digit is at least one non-zero digits, then only I will treat it this is started. And the last one is tight. Tight, because as I have explained just a few minutes before, tight means, let's say you have all the prefixes same as this. Then how to find out the limit? Limit means what are the options of digits which we can keep at any index. For example, if you have so when you kept 0 here, the limit is 0 to 9, right? So the limit is 9. We can keep all the digits from 0 to 9. But if you had 1 here, which is exactly same as the original number, then the limit was 0 to 2. How to decide whether the limit is 0 to 2 or 0 to 9? That would be based on your this tight. Tight would tell you whether this prefix is same as this or not. So these four are the only states that is required to solve this problem. So apart from it, it's just an implementation, nothing else. So I have explained almost everything in this problem. So yeah, let's look at the code. If you have any missing pieces, once you look at the code, you would understand everything. So spend some time, solve at least one digit DP problem and DP problem, you would understand it. So let's look at the code. This is the code. So as explained the explanation part, for like to find out all the balanced number from low to high, we will call solve of high minus solve of low minus 1. So this solve function will give you all the balance numbers from 1 to that number, right? So here it will give you from 1 to x. So first check if your x is less than 10, because we know that it must have at least 2 digits, right? So if it is less than 10 means that it can have at most 1 digit. So just return 0. Otherwise convert it into a string, find out how many digits are there. Then we will create a DP value. So there are 4 states. If you see, index, difference, started and tight, right? So this is the function. Let's keep it aside. Then we will call this difference 0 0. Initially you start with index 0, initially 0, difference is also 0. So initially started would be false, because started means you have at least one non-zero digits. If it's all zeros, then it's not started currently, because to start you must have at least so you like you must start with one, right? One to that max number. And tight is initially true, because this is same as the original number, right? So these are the four like initial values. Now let's go to the DFS function. So if you have I equals to n, means that you have like completed all the place. Like, so here if you see there are 4 places, right? So all the 4 places are filled. Then just check whether you started or not. You must be started, and difference is 0 or not. So this difference must be 0, right? Because the second condition was that it must have, the difference must be 0. The sum of digits at even position must be equal to sum of digits at odd position. So just check started and difference equals to 0. It will return true, all false. Otherwise, create a tuple of all these 4 states. So just check if the DP is already calculated. So if the DP count of key is already there, then just return this. So the reason why I have used map here, I have not used conventional. If you have solved DP problem before, you might be using something like DP X, Y, J, Z, and so on, right? So here you used to have an array of like 3D array or 4D array. But here the thing is, your difference could be positive or negative, we don't know that. And here if you see, for array your index must be at least 0, right? But here if you see your difference, right, because in difference you have to subtract and add the digits, right? So the difference could be negative also. So I mean, I could have used some extra code to handle that, but I mean, just to be on a safer side and the code is easy, that's why I have used map here. It's okay, you can also use that. There is, the complexity is not going to change drastically, it will be just small, I mean small. um, I mean, it's not a optimized one, but it would be accepted, it would be under the complexity. So just use map here. Like, so you can also use unordered map maybe, but it's fine, we don't have to worry about this value. So just calculate this tuple, like tuple of all these 4 number. Just check if the DP is already calculated, right? That's similar to how you used to do DP X, Y, Z, and W. So let's say you used some array kind of mechanism, right? So here you have to check. So here you will be checking what is my if DP of I diff started and tight. If that is not equals to -1, then just return that value, right? DP of this. But here instead of that I have used some map. So here you used to do DP of this if you are using some 4D array mechanism. But for map, just check if the DP is already calculated or not. Otherwise, we will first find out what is the limit. The limit means what is the, I mean, what are the digits that we can place at this index. So I mean, that is exactly same how I've explained the explanation part. If your tight is already there, if so if it is tight, you can only keep up to 0 to that digit. Otherwise you can keep from 0 to 9. This is your result, this is your answer. Now go through all the possibilities of digit from 0 to limit, right? This would be your new started. Your new start would be either it is already started or your digit is non-zero. So started means you must have at least one non-zero digits. Now new difference would be, so this is the original difference. Now let's say I want to keep D here, right? So if it is started, so just check if your index is even or not. If your index is odd, just do difference plus equals to D, otherwise difference minus equals to D. And after that just call this function once again. So this will be recursive function. So go through index I plus 1. For this will be your new difference, this will be your new start, and this would be either it is tight, or if it is not tight, then just check if your D is same as limit or not, right? So here if you see uh, here, if you have 1 2 3 4, right? If you keep 1 here, then if you keep 2 here, right, then it would be again tight. So initially the tight was true, If you keep 1 2 here, it will be tight once again. But if you keep 1 1 here, it won't be tight, because 1 1 is less than 1 2. So just if it is already typed and your digit is same as this limit, and after that just store these two information and return, right? So dp of key equals to answer and return result. So this can be written in one line: return dp of key equals to result. So yeah, that's all about this problem. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching. Just spend some time, you would understand everything, I'm sure. Like so today's contest was not that hard. Fourth problem was a good one, but it like, so it's a standard digit problem. If you have solved at least one digit problem, you can solve it easily, right? And that's all about today's contest. Thanks for watching.